Here we have some interesting features of a function, the maximum and minimum points. Now, this is a function, and let's call it y is equals to f of x. And a global minimum is the minimum value of y in the entire domain, okay? And it happens that this point here is the global minimum. So global minimum. Okay. A global maximum is the maximum value of y in the entire domain. And it happens that this point here is the global maximum. Okay. We also have a local maximum, which is the turning point where the value of the first derivative is equals to 0, or where we are at the top of the mountains. Okay, so this point here and this point here are basically what we can call, okay, so these 2 points are the top of the mountains, and these guys are called the local maximums. Okay, we also have the local minimums, and this is the turning point where the gradient is equals to 0, or the slope is equals to 0, and where we are at the bottom of the valleys. So the bottom of the valleys, this will be these 2 points again, here and this point here. This is called local minimums. Okay, so these are some interesting features of functions, and we are going to learn about this in detail here. So the first derivative test can be used to determine the maximum and minimum points. And here are graphs of 3 functions, and I'm going to discuss a few features, okay, based on what we've just talked about. So again, this is y, this is x, y, x, y, and x. Sorry, that's meant to be y. So y here and x. Okay. One of the things that you need to realize is at this point here, we've already discussed this before. F dash x is equals to 0. Here, f dash x is equals to 0. And at this point here, f dash x is equals to 0. May have just to this point here, f dash x is equals to 0. Okay, let me start with the first graph. Now, on the left of this graph, f dash x is greater than 0. Of course, the slope is positive. And on the right, f dash x is less than 0. The slope is negative. Okay? And by the way, let's call this point here. Let's call this point here x is equals to c. Okay? Now we can represent the information on the first graph below. Okay? We can represent this information below here. And we can represent it on something called a Venn diagram. Okay? For the values of x. So we can represent this information on the Venn diagram. Now this will be the point at x is equals to c. So somewhere here. Now what we want is the signs of the first derivative. Okay? We know that here the first derivative is 0, here it's positive, and here it's negative. Okay? So, what can we conclude from the first graph? We can conclude and say that suppose x is equals to c is a critical point on the graph of y is equals to f of x, If f of x changes from positive to negative at x equals to c, then y is equals to f of x has a maximum value at x equals to c. And this is on the first graph. So we can say that suppose x is equals to c is a critical point. On the graph of y is equals to f of x, okay? Then from graph 1, we can say that if f dash x changes from positive to negative, and this is at x is equals to c, then y is equals to f of x has a maximum at x is equals to c. Okay, this is an observation from the first graph. Okay, from the first graph we can notice that that this is true. Now let's move to the second graph. I may need some space here. So we know that at this point f dash x is equals to 0. And we can call this point x is equals to c as well. Now we know that on the left the first derivative is less than 0. We are going downhill. And here we are going uphill, so that's greater than 0. We can represent this information again on a sign diagram, just like what we did in the previous. Okay, so this is x, and we want to find, so this is x, but what we are interested is in this sign of f dash x. At this point, x equals to c, the gradient is 0. Here, it's negative. Here, it's positive. So what can we conclude? We can conclude below here that if f of x changes from negative to positive at x equals to c, then y is equals to f of x has a minimum. Okay, if the gradient changes from negative to positive, at x is equals to c, then y is equals to f of x has a minimum. Okay, how about the third graph? Now for the third graph, we can notice that on the left, the first derivative is greater than 0. Okay, the slope is positive, and here the slope is positive. Okay, so how can we represent this on the sign diagram? We can represent it this way. So this is x. Now what you're interested is in the signs of the gradient. Now we know that here the gradient is 0 because that's a stationary point. Here it's positive, and here it's positive. Well, in the third graph, we really don't have a maximum or a minimum point. So what will be our conclusion below here? Our conclusion will be that in graph 3, or in general, if the gradient does not change, or does not change sign, at x equals to c, then y is equals to f of x has no local maximum or no minimum at x equals to c. So we do not have a maximum point or a minimum point in the third graph.